For filtering the switching transients from a phase angle-fired silicon-controlled rectifier heater, especially when using it with lightweight systems needing tight control, several approaches can be considered. Firstly, consider using a three-phase delta filter. This filter is designed for a voltage range that includes both 208 volts and 240 volts. You can leave the third terminal open, as it's not needed for your two-phase application. Secondly, if you prefer a single-phase filter, you can use one in conjunction with a line transformer. This line transformer will convert the two-phase voltage of 240 volts line to line to a single-phase voltage of 240 volts line to neutral. Then, connect the line connections of the filter to the two live wires of the line-to-line power source. Regarding finding a suitable 50 amp outlet and plug for a 240 volts welder, several options exist. The L14.50P plug and L14.50R outlet are commonly used for 240 volts welders with a 50 amp rating. Another popular option for high amperage welding equipment is the NEMA 6.50P plug and NEMA 6.50R receptacle. When selecting line filters and outlets, consider listed options for safety and reliability. For example, Sensata Technologies offers a three-phase delta filter with part number 408913. It's rated for 50 amps and handles both 208 volts and 240 volts. Also, Amaker Power Systems provides a 50 amp L14.50R outlet with part number 4055 and a matching L14.50P plug with part number 4062. These readily available options are the L14.50 configuration. When dealing with electrical systems and components, especially at high currents and voltages like 50 amps and 240 volts, it's crucial to prioritize safety. Always ensure that all components are properly rated for the intended application and that all electrical work is performed by qualified personnel who are familiar with applicable electrical codes and standards. Furthermore, when using filters, it's beneficial to understand how they operate and their limitations. Filters work by attenuating certain frequencies, reducing the noise that is transmitted along the power lines. In the case of phase angle-fired silicon-controlled rectifiers, the rapid switching creates a wide spectrum of frequencies that can interfere with other electronic equipment. The filter helps to reduce these frequencies, preventing interference and improving the overall performance of the system. When installing a filter, it's important to follow the manufacturer's instructions carefully. This includes ensuring that the filter is properly grounded, as grounding is essential for the filter to function correctly. The filter should also be located as close as possible to the source of the noise, which in this case is the silicon-controlled rectifier heater. This minimizes the amount of noise that can radiate from the wiring between the source and the filter. When choosing a filter, it's important to consider the frequency range that needs to be attenuated. Filters are typically designed to attenuate frequencies above a certain cutoff frequency. The cutoff frequency should be chosen so that it attenuates the noise generated by the silicon-controlled rectifier but does not interfere with the operation of other equipment. It's also important to consider the voltage and current ratings of the filter. The filter should be rated for the voltage and current that it will be subjected to in the application. Using a filter that is not properly rated can result in damage to the filter or other equipment. When using a transformer to convert the two-phase voltage to a single-phase voltage, it's important to ensure that the transformer is properly sized for the application. The transformer should be able to handle the full load current of the silicon-controlled rectifier heater. Using a transformer that is too small can result in overheating and damage to the transformer. Additionally, the transformer should be properly grounded to prevent electrical shock. When selecting an outlet and plug, it's important to choose one that is compatible with the voltage and current requirements of the equipment. The outlet and plug should also be rated for the environment in which they will be used. For example, if the equipment will be used in a wet or damp environment, the outlet and plug should be rated for wet locations. It's also important to ensure that the outlet and plug are properly wired. Incorrect wiring can result in electrical shock or damage to the equipment. The wiring should be performed by a qualified electrician who is familiar with applicable electrical codes and standards. When working with electrical equipment, it's always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It's also important to energize the equipment before working on it. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the equipment. Before re-energizing the equipment, it's important to double-check that all connections are tight and that there are no loose wires. It's also important to inspect the equipment for any signs of damage. If any damage is found, the equipment should be repaired or replaced before being re-energized. In summary, filtering phase angle fired silicon-controlled rectifier heater noise involves using appropriate filters, possibly in conjunction with transformers, and selecting the correct outlets and plugs. Ensuring proper grounding, following manufacturer's instructions, and adhering to safe work practices are paramount for safe and effective operation. Remember that electrical work should be conducted by qualified individuals familiar with electrical codes. When troubleshooting electrical issues, a systematic approach is essential. Firstly, verify the power supply. Ensure that the voltage levels are correct and stable. Use a multimeter to measure the voltage at various points in the circuit. Secondly, inspect all wiring connections. Look for loose connections, corroded terminals, or damaged insulation. Tighten any loose connections and replace any damaged wiring. Thirdly, test the components. Use a multimeter to test the resistance, capacitance, and other parameters of the components in the circuit. Replace any components that are out of specification. Fourthly, isolate the problem. If the problem is not immediately apparent, try isolating different sections of the circuit to narrow down the source of the problem. Disconnect components or sections of the circuit one at a time and see if the problem goes away. Fifthly, consult the documentation. Refer to the manufacturer's documentation for the equipment to get more information about the circuit and its operation. The documentation may contain troubleshooting tips and diagrams that can help you find the problem. Sixthly, seek expert advice. If you are unable to resolve the problem yourself, consult with a qualified electrician or electronic technician. They have the knowledge and experience to diagnose and repair complex electrical problems. When dealing with electrical noise, it is crucial to understand the different types of noise and how they can affect electronic equipment. There are two main types of electrical noise: conducted noise and radiated noise. Conducted noise is transmitted through the power lines, while radiated noise is transmitted through the air. Filters are effective at reducing conducted noise, but they may not be as effective at reducing radiated noise. Shielding can be used to reduce radiated noise. Shielding involves enclosing the electronic equipment in a metal enclosure that blocks electromagnetic radiation. The metal enclosure should be grounded to provide a path for the noise to dissipate. Another technique for reducing electrical noise is to use twisted pair wiring. Twisted pair wiring involves twisting two wires together to cancel out electromagnetic interference. The twisting helps to ensure that both wires pick up the same amount of noise, which cancels out when the signal is transmitted. In addition to these techniques, it is also important to follow good grounding practices. Grounding helps to provide a low impedance path for noise to dissipate. The grounding system should be designed to minimize ground loops, which can create additional noise. Ground loops occur when there are multiple ground paths between two pieces of equipment. This can cause current to flow through the ground paths, which can generate noise. To minimize ground loops, it is important to use a single-point grounding system. In a single-point grounding system, all of the equipment is grounded to a single point. This helps to ensure that there is only one ground path between any two pieces of equipment. When selecting electrical components, it is important to choose components that are designed to minimize electrical noise. For example, choose resistors and capacitors with low inductance and capacitance. These components will generate less noise than components with high inductance and capacitance. It is also important to use shielded cables and connectors. Shielded cables and connectors help to block electromagnetic radiation and reduce noise. When installing electrical equipment, it is important to follow the manufacturer's instructions carefully. This includes properly grounding the equipment, using shielded cables and connectors, and following good wiring practices. Following these instructions will help to ensure that the equipment operates safely and reliably and that electrical noise is minimized. When dealing with electrical circuits, it is also important to understand the concepts of impedance and reactance. Impedance is the total opposition to current flow in an alternating current circuit. It is a combination of resistance and reactance. Reactance is the opposition to current flow due to capacitance and inductance. Capacitive reactance decreases as the frequency increases, while inductive reactance increases as the frequency increases. Understanding impedance and reactance is important for designing and troubleshooting electrical circuits. For example, when designing a filter, it is important to choose components that have the correct impedance to attenuate the desired frequencies. When troubleshooting an electrical circuit, it is important to measure the impedance at various points in the circuit to identify any problems. In summary, filtering electrical noise involves a combination of techniques, including using filters, shielding, twisted pair wiring, and good grounding practices. Selecting the correct electrical components and following the manufacturer's instructions are also important for minimizing electrical noise. Understanding the concepts of impedance and reactance is also important for designing and troubleshooting electrical circuits. When working with electricity, safety should always be the top priority. Always follow safe work practices and consult with a qualified electrician if you are unsure about anything.